In this video, I'd like to talk about the number of solutions to a system of equations. And specifically, we're going to look at the graphs of those systems. So, with a system of equations, remember with these linear systems that we're going to have one line here and one line here. And typically, these two lines are going to cross in one point. But there could be two other scenarios. So, let's look at these three scenarios first. So you have the most typical case where you have these two lines, and these two lines are just going to cross at one point. So if that's the case, then this is choice letter A. You have one solution. And like I said, this is the most typical case. This is what usually happens. But it's not what always happens. You could also have a scenario where there are no solutions. And graphically speaking, what's happening there is you have these two lines that are going to be parallel to each other. So if the two lines are parallel, they're not going to cross. So we can say two parallel lines. And you want to think about it, what makes a line parallel? Well, that's when the slope is the same in each of these. So we can say this is when they have the same slope. And if this is the case, like I said, this is when you have no solutions. So we can write that down, that when they're parallel, when they have the same slope, you have no solutions. They're just never going to cross each other, and you're never going to get that point of intersection. Now, the final scenario, when you have an infinite amount of solutions, is essentially when you have one line, and then you have another line that is directly on top of it. So this is kind of hard to draw, but we can just say two lines on top of each other. And another way to put this, you can say that they're the same line. And if they're the same line, or if they're on top of each other, this means they intersect at every single point. So this is intersects at every point. Or in other words, this is the case where you have infinite solutions. So essentially, we need to figure out, do we have this normal case where the two lines are just going to intersect? Do we have a case where they're parallel and have the same slope and we're going to have no solutions? Or do we have the case where the two lines are the exact same line? And usually you'll see that one line is just a multiple of the other line, and when you simplify the one that's a multiple, they end up being the same line. And for these problems on the Khan Academy, you're going to have this interactive grapher. I didn't put that in down below, but essentially with that interactive grapher, you can graph both of these lines and see what the scenario is. Is it the same line? Are they parallel lines? Or is there just one solution? And in a later video, we'll look at how to deal with these algebraically. And from the algebraic standpoint, the two kind of different or extreme choices where you have no solutions or infinite solutions, in both of these cases, the slope is the same in each line. Since when they're parallel, they definitely have the same slope, just different y-intercepts. But when they're the same line, then they're going to have the same slope there as well. And so if you can look at this and notice that they don't have the same slope, that means they're going to intersect with each other. And that's the case here, because the slope on this is 1 and the slope on this is 2. So we do get one solution. But let's approach it from a graphical point of view. Let's actually try and graph these lines and see what happens. So let me make some space, and I'll just rewrite these. We have that y is x plus 1, and we also have y is 2x minus 5. And so I will draw a rough picture of each of these. Let's actually go over here. So let me get a coordinate plane going. And now that we have our coordinate plane, so we're going to match this up to our slope-intercept form since they're already solved for y. So with this one, our slope is 1 and our y-intercept is 1. So we can plot it at 0, 1, and then our slope means we go up 1 over 1. So there and here and so on. It goes through there. And I'll get a rough straight line going here. And for this one, we have y is 2x minus 5. So let me do that in a blue color. So its y-intercept is at -5, so that would be here. And it's got a slope of 2, so it goes up 2 over 1, up 2 over 1, up 2 over 1, and it keeps going. It's fairly steep, or it's twice as steep as the other one. And so I'm not sure where these are going to cross each other, but they're not parallel. So eventually they will cross. And we could, in theory, find that exact point. In fact, they're both set equal to y, so we could set the equations equal to each other, where you have x plus 1 equals 2x minus 5, and then solve the equation. Add 5 to the other side, subtract x, you get x is 6, you plug that into y equals x plus 1. So 6 plus 1, y would be 7. And so you get a coordinate point, 6, 7. And that's roughly right about there where we drew it. But these two lines do intersect. And if you wanted, you could actually figure that out. So in this case, we get one solution because this is the typical case where the two lines are going to come together, where they're not the same line and they're not parallel, so they don't have the same slope. And if they don't have the same slope, that means that for sure they will eventually cross each other.